Hello everyone, welcome to video lectures on data mining and data warehousing, Module 4 classification.
Now let's see this left subtree. Okay, let's continue with our classification. So anyways, we are done with our right subtree. Now we are in the left subtree. So here we have taken the attribute marital status, wherein the two values of marital status are single and divorced. So we have clubbed the single and divorced into one. Why? Because single has total 2 records belonging to no class, and again 2 records belonging to yes class. So this became impure. As well as divorced also you have divorced one record belonging to yes class and the other record belonging to no class. So both are impure. So we have clubbed that into one, and here we have added a class label, or we have added the leaf node as defaulted is equal to yes. I'll just tell you why this class label defaulted is equal to yes has been added for single divorced instead of class no. Class yes is added. So you just see here, count the number of records. Single has equal count for both no class as well as for yes class. So there too and here too again. What about divorced again? Divorced here has one yes and one no. So total how many records for yes? 3 records for yes, and that is inclusive of single and divorced. And again for no class, again there is 3 records total for 3 records total, that is belonging for class yes. So there is equal count of records for both single and divorced. So here you can add, there is no majority, right? So for both class yes or class no, you have total number of records, that is 3 here. That is why you can add either defaulted class is equal to no here as leaf node for the single divorced, or you can add defaulted is equal to yes. So out of which we have added defaulted is equal to yes. So it is left to you. You can add any one, right? So here single divorced, the class label we have added as defaulted is equal to yes. Okay, yes. So now remember here, whenever we are here we are speaking about this marital status, and this marital status has been added under no of homeowner. So you are just seeing here which are the records you have seen where homeowner is equal to no, only those records are supposed to see, right? So just see here once again, let me tell once again over here this part. So we are concentrating on only those records where homeowner is equal to no and marital status is equal to married. Let's see this right subtree first. Homeowner is equal to no and marital status is equal to married. So just concentrate on those records. Homeowner is equal to no, marital status is equal to married. Again, homeowner is equal to no, marital status is married. Homeowner is equal to no, marital status is equal to married. So here no, married, both belonging to class no, count is 1. Again here I cannot consider this. Why? Because homeowner is equal to yes here, and that classification we have already done. So here I am concentrating on only homeowner is equal to no, right? So here homeowner is equal to no, married, class no, that's count 1, and let's not take this, let's go to this. Homeowner is equal to no, married, and that is also belonging to class no. So total, and then again one more record we have, homeowner is equal to no, married, and belonging to class no. So total 3 records for married where homeowner is value is equal to no and belonging to class no. So no other records we have here, only 3 records, and all 3 are belonging to class no. So we have added the leaf node here as defaulted is equal to no, and this became our pure classification. Coming to the left hand side, we have here homeowner is equal to no and marital status is equal to single and divorced. We have clubbed both single and divorced, right? So concentrate only on those records where homeowner is equal to no. So homeowner is equal to no, you can come here, third record, homeowner is equal to no and single belonging to class no, count became 1. Again go to, we'll see only single records, okay? Then again we have here homeowner is equal to no, single but belonging to class yes. So 1 count for class no and 1 count for class yes we got. Again here come homeowner is equal to no and single belonging to class yes. So we got count 2 for class yes, and whereas count 1 for class no, and we are speaking about marital status is equal to single here and homeowner is equal to no. So count for yes became 2 and count for no became only 1. Majority is class yes here, remember this. And then we'll go to this divorced. Homeowner is equal to no and marital status is divorced. So homeowner is equal to no, homeowner is equal to no, yes, fifth record. Marital status is divorced, class became yes, count is 1. Again here we cannot take this. Why? Because homeowner is equal to yes, right? So we have only one record where homeowner is equal to no and class marital status is divorced belonging to homeowner is equal to no belonging to the and marital status divorce belonging to class yes. There is only one record, correct? So that is why the majority here became that is consisting inclusive of single as well as divorced. Majority of the records are belonging to what? Class yes. So single we found there are 2 records belonging to classes. Divorced we found 1 record belonging to classes. So here you can find homeowner is equal to no, marital status, single and divorced. There are majority of the records which are belonging to classes. So we have added here the leaf node as defaulted is equal to yes for this particular left subtree. Okay, I hope you all understood this. So here remember, you are not seeing only this column marital status. Now here you have added this as an attribute. This is a branch for your homeowner attribute, right? So that is why you have to count, you have to see both homeowner column as well as marital status column. But which value you're going to concentrate here? Only homeowner is equal to no record you're going to see here. So that is what you have to remember, right? Okay, now you just see here we have first part here as pure classification. Here also we got pure classification for married. What is impure here? That is single divorced is impure. Why it is impure? Because majority records belongs to classes, but still there are few records here which belongs to class no. Still there are few records here, see, belonging to, sorry, here still there are few records homeowner no, single belonging to class no. Again here we have any other no. So here still we have one record where is single no belonging to class no. So this became impure. So can we make it still more pure? We'll try to make it pure. So how do we make pure here? This part only by adding the next attribute, that is by adding the next column here. So the next column is what? Annual income. So we'll continue with the Hunt's algorithm here, that is next step, step D. So here we have added the next attribute. See here where I have added the next attribute. The first part remains the same, root node remains the same, homeowner only, and the left subtree is the same, still the same continuation. So again here right subtree, this first part remains the same, no, marital status remains the same. Again here right subtree married and defaulted no also remains the same. We are not touching that. What we are editing or whatever the changes we are making is only for this left subtree where marital status is now single divorced, and now here we have added the new attribute, that is annual income. Now what are the values for annual income we have? You can see here these, it is neither binary nor it is having 3 values for this, but it has continuous values right from 60k. You can see 60k, 70k, 75k, 85k, and it goes on. Several values you have for this annual income. Now what are you supposed to do? Yes, can we do this something kind of grouping? So what is this grouping type of? Can we have a range of values here? I want to convert this annual income into a binary attribute, like how we did marital status, we converted into binary having only 2 branches. Well, let's do this annual income, convert this also into binary attributes. How do we convert? Can we have a range here? So what range do we have to pick up here? So you can see several values over here, right, belonging to class no and yes. So let me break it up into 2 groups. One is greater than 80k. People whose annual income is greater than or equal to 80k and less than or equal to 80k. Let me break it up into 2 groups, right? So you can see here annual income is attribute added, and we have broken it up into 2 groups. Add 2 branches. Left one is saying that people whose annual income is less than 80k. The right one says that people whose income is greater than or equal to 80k. So what are we supposed to do now? You just have to see those people whose annual income is less than 80k, whether they are belonging to class no or class yes. Again, the same thing applies over here, right? So let's now come back. Homeowner value. Now what records you're going to see? Where homeowner is equal to no value, which has marital status is equal to the single, or marital status is equal to divorced value, and then you come to annual income and see whose annual income is less than 80k. So let's see this less than 80k first, right? So now what records you're going to see here? Only those records whose annual income are less than 80k. So less than 80k, one record you got. 70k is one annual income, 60k is the second annual income less than 80, and next one is 75k. Only 3 records you have whose annual income is less than 80k. Sorry again. Yes, so here 1, 2 and 3. There are 3 records whose annual income is less than 80k. But you also have to see, you just don't have to see only this annual income. You also have to see the marital status, whether it is single and divorced only, and also the homeowner value, whether it is equal to no, because it comes under this category, right? Okay, so you just see here, homeowner is equal to no, yes. Marital status is equal to single, yes. Less than 80k, yes. So what is the class it belongs to? Class no. So the count became 1 for class no. Next again come for annual income less than 80k, that is here 60k. So homeowner is equal to no, yes. Married, but we are not seeing here married column, so you don't have to consider this row at all. Skip this. Go to the next one where annual income is less than 80k. So what is this? Can you just see here? Homeowner is equal to no, marital status is married. No, I don't want this. I'm not interested. I'm looking for only single or divorced, right? So we have only one record till now. What we got? Less than 80k, where homeowner is equal to no and marital status is single, and it is clearly saying that it is belonging to the class default borrower is equal to, or the class is no, right? So clearly, can I write add the leaf node as defaulted is equal to no? Yes. So now you can see here, I have added the leaf node and this became the pure classification. Anymore, no touching this left subtree. Now come to this right subtree. So what is this right subtree saying? Now you have to look for annual income people whose annual income is greater than or equal to 80k. So again, see, remember, you're concentrating on homeowner is equal to no, and again marital status of people either single or divorced and whose annual income is greater than or equal to 80k. So just see over here, homeowner is equal to no, married. Am I interested in this married now here? No, I'm looking for only single or divorced. So don't see this record. Again, next one, no, third record, no. So can I consider this record? No, because this is less than 80k. I cannot consider this. Fourth record, can I consider? No, this is married. Fifth record, yes, you just see homeowner is equal to no, marital status is divorced, and then annual income is greater than 80k. So just see, count the record. It belongs to class yes. So the count became 1 for class yes. Class yes, count became 1. Go to the next one. Can I consider this? No. The next one, homeowner is equal to yes, it is saying no, I'm not interested in this. Next one, homeowner is equal to no, single, and it is greater than 80k. Yes, I'm interested. It belongs to class yes. So the count became 2 for class yes. Go to the next one. Homeowner is no, but it is married. No, I'm not interested. The next one, homeowner is equal to no, single, and then it is 90k, greater than 80k, yes. And it belongs to classes. Yes, good. So here all 3 records what we found for this, homeowner is equal to no and marital status is single. Here I got all 3 records belongs to which class? It is class yes. So clearly I can close my eyes and add the leaf node here as defaulted is equal to yes for the annual income whose values are greater than or equal to 80k. Correct? So homeowner is equal to no, marital status is single, divorced, annual income is greater than or equal to 80k. Leaf node is directly added as defaulted is equal to yes. So here this became pure classification, right? Left side also it became pure classification, and rest all other are already purely classified. So should I have to further classify here? I do not have to further classify here. Anyways, my attribute list also got over. Only 3 attributes I have. Further classification is not required. This is called pure classification, and this is our Hunt's algorithm. I hope it is clear. So all the steps of Hunt's algorithm you just have to recall again. So you see here, all that you have to do is go on adding the attributes. Okay, so start from the first attribute, start from the root node, and then add the leaf node there. Leaf node should be always, remember, it should be class label. So when you're adding the class label, make sure that majority number of records only you have to consider, and that class label you have to add as a leaf node. So that is the point that you have to remember, and this is a very important concept exam point of view also. Okay, right? So I hope it is clear. Students, let's continue with the methods for expressing attribute test conditions. Okay, so what is this? You just see here, we have just discussed about Hunt's algorithm, where you had already seen this part in the tree structure. So what is this basically saying? Body temperature, we have already seen one tree structure, one data set about the mammals and non-mammals. I hope you remember. See, body temperature when it is warm-blooded, body temperature has only 2 values. This you call it as binary attributes. So you can have only either, left subtree and right subtree. One is for warm-blooded, the other one represents cold-blooded. So you call this as binary tree. So you call this as a binary attribute. And you have other type of attributes also. The next attribute is a marital status. You have already seen the values for it. So 3 types of values you have there. You call this as categorical. So wherein single, divorced and married, this can be converted into binary again. So you know what are the 3 ways of converting into binary. So wherein 2 values you can merge and form it as one particular subtree, and the other value you can form it as left subtree here. So any of these 3 ways you can split. Next you have ordinal type of attributes, wherein that also can be done in this way. You can split it in this way. See, you can have 2 values. If a shirt is an attribute, it has 4 values. For what are the values? Small, medium, large and extra large. So these 4 values can be divided into 2 again. Right, so that can be done. And then the last type of attribute is continuous attribute. This also can be split in this way. See, you can have an attribute something like this, wherein attributes itself saying the condition, giving you the condition if annual income is greater than 80k. So if the condition you are specifying inside the attribute, then you have only 2 values, yes or no. But see here, annual income itself, if you take as an attribute, then these are the different values that it has. So you can have several values or range of values here as a condition. Okay, so these are the different ways of splitting. Okay, and now let's come to the next part, important part, that is how to determine the best split. So what is the meaning of best split? See, you have a data set given to you. Out of the given data set, we'll just see that previous data set that we had taken. Yeah, this was the data set that we had taken to do the classification, right? So here in this data set, we had started with the attribute homeowner. Who asked us to start with the homeowner, or is there any such compulsion that you have to start with the homeowner? No. So you can take out of these 3 attributes what we have. Any one attribute can be taken as a root node. So, but before selecting the attribute, you should know, is that attribute is that attribute going to be the best attribute for splitting? Okay, so do we know here whether homeowner attribute is the best attribute to choose here for splitting or for doing the classification? No, we did not know. Blindly we had taken homeowner as attribute to do the classification in the first step. Then the next step we continued with the next attribute. Then in the last step we added the last attribute, right? So there is actually a way to find out whether the chosen attribute is going to give us the best result, or whether the chosen attribute will give us the right classification or not. So choosing the best split is one of the challenge. So we'll see how to find out the best split. Yes, just let's see this example. Okay, so you have an attribute. assume this is one of the attribute. What is the value? It's saying own car. So whether a person owns a car, this is one of the attribute. Next attribute in the data set is car type, and the last attribute is, say, this is one more attribute, that is something like student ID, USN. Okay, so what is this attribute own car has? It has two values. Well, it is asking whether you own a car or not. There can be only two values, yes and no. And you see here the data set what you have for this particular thing, for this particular attribute, that contains, say, two classes. Here C0 and C1, you can see that contains two classes. I hope you all know what are the two classes. What do you mean by class? So class represents the last column in the data set. In our previous example, we had two classes, that is defaulted is equal to no and defaulted is equal to yes. Same way here, C0 represents one such class and C1 represents the other class. Now here, what is it saying? It is giving us the count of records. Okay, you just see, if the person owns a car, that is, if the value is yes, that means it is saying there are 6 records in the data set which is representing owning own car is equal to yes, and that is belonging to class C0, and 4 the other remaining records there where the person owns a car belongs to the class 1. Right, so there are total 10 records here in the data set, where out of which 6 belongs to C0 and 4 belongs to C1, whose value is own car is equal to yes. Similarly, go to the other value there, own car is equal to no. There, when it is equal to no, you can see here 4 records belongs to this and 1 record belongs to C1. Yes, so basically what are we trying to see here is, it is saying that where there are 6 records which belongs to C0 satisfies the given condition, whereas there are still 4 records which belongs to the other class which also satisfies the condition. But here what is our intention? Our intention is to do the classification. Right, so the classification should be something like all the records here which belongs to a particular class should satisfy the given condition. There should not be any mixture of records belonging to 2 different classes, right? So this is not the good classification. Come to this again, it is the same thing. 4 records for C0 and 6 records with C1 satisfies the given condition. This is also not a good classification. So this attribute what you have chosen for doing the classification is not the right or the best attribute. Go to the next one, car type. One of the value is family, the other one is sports, and the third one is luxury. Just see here, if the car type is family, you can see there is one record which clearly belongs to the class C0. Yeah, 1 record belonging to class C0 and 3 records belonging to class 1 satisfies the given condition. Car type is family. So total there are 3 records belong to class 1, and it is saying maximum only 1 record belong to class 0 is family car type. So here this is almost the better classification, you can see, because maximum majority of the records are belonging to class 1 and only 1 record out of which is saying C0. And next again you can see here sports car. There are all 8 records which whose value, all 8 records there says that it belongs to class C0. That means the car type, where the car type value is sports, it says that all are belonging to the class C0. There are no records which belongs to the other class. So this becomes the best classification. Why? Because clearly it is classifying and saying that all the records where car type is sports belongs to class C0. Similarly, come to this luxury also. Majority of the records here belongs to class C1. Only 1 record here belongs to class C0. So that means what here? This is also best. So car type attribute what you've chosen is one of the best attribute, because it is doing almost it is doing the right classification. Similarly, you come to the student ID. So student ID is USN. You have several split here, multi-split, you call it as multi-split. And now you can see here what is it, all the classification. See here, see the one record belong to class Z and no record for class 1. So here that means this split is the best, it is doing the right classification. Here also it is doing the right, here also, and everywhere it is doing the right classification, and you can call this as the best split. So car type and student ID are the best split, whereas own car here is not the good one, right? This is how you choose the best split. And here we'll see the next measures also to do this. There is a proper way to do this, I mean, to determine the best split. Okay, so we'll just see here. Yes, so you call this as the two types of you can say the measure here. So what is it saying? This particular thing is saying that 5 records, this is a classification way, number of records, this is a count of records after the classification, count of records belonging to class C0, the count of records in the data set belonging to class 1. So this we call it as non-homogeneous, and here you call this is not a good classification because you have mixture of records belonging to two different classes. High impurity, you call it as high impurity, high degree of impurity is high. So what about this? See, there are, after classification you can see 9 records belonging to one class C0 and only one record here belonging to class C1. So total 10 records you have. Out of those 10 records, maximum records are belonging to C0. So this became almost the better classification. So almost you can say it is a best classification, and wherein the degree of impurity is very low, right? So we'll just see there, continue. So there are 3 measures. Like I already said, there is a proper way to determine the impurity, or there is a proper way to find out the best split. So those are the 3 measures here, measures of node impurity. These are the 3 measures. Basically is used to check impurity level, right? Okay, so entropy, there is a formula here. I'll tell you, find out what is each of this factor saying. So this is a formula to calculate entropy. So here the next measure is Gini, and this is the formula to check or to calculate the degree of impurity. Next, classification error. There are 3 measures: entropy, Gini, and classification error. Okay, so we'll just see this formula in detail while solving the problem. Okay, and then yes, we'll solve the problem, for which we'll just go to the solved problem. Yes. Yes, so here we have, I have already circulated this particular problem to calculate the best split, to find out the best split, or to do the right classification. Okay, or in other words, the question may be calculate the degree of impurity. Okay, so all 3 measures we will use here to calculate the degree of impurity. Okay, one thing you have to know here, all 3 measures, Gini, entropy, and classification error, all 3 are measuring the impurity level. If the answer what you get after solving the problem, the answer, I mean after substituting the values in the formula, answer if you get it as 0 for all the 3 measures, or any one you take here, if the answer is 0, the meaning is the degree of impurity is 0. When the impurity is 0, that means what? The classification what you're doing or what you have already done is the best classification. That means impurity is 0. Or if the answer that you get there for entropy or Gini or classification error, if the answer that you get after solving, after substitution, answer is 1, that means the degree of impurity is 1. That means the degree of impurity is high. So we are not expecting the answer 1 or maximum value. We are always expecting the value there for all the 3 measures 0 or almost equal to 0. Okay, so low degree of impurity we are expecting. That means yeah, that is how you do the solve the problem. Okay, fine. So we'll just see here, after solving the problem you will realize what exactly it is, right? So just see this data set once. So what is this data set saying? There are total 12 records here, 12 rows here, and there are two attributes. I have generally taken the attribute as A and B, and the class, you see, I have taken only two class labels, that is 0 and 1. Okay, for your understanding purpose, I have made the data set very simple. So you can see the 12 records. A value has only two values, yes or no, and here B also attribute has two values, yes or no. So both are binary attributes. Class also is a binary, it has only two classes, 0 and 1. So you can just see here how many records are belonging to class 0 out of 12. You can see 3, 4, 5, 6. There are total 6 records belonging to class 0, and how many records belonging to class 1? Remaining 6 records are belonging to class 1. So total 12 records. So before split, you can see there are total 6 records belonging to class 0 and 6 records belonging to class 1. So that is what I have written here. Class distribution. So what is class distribution? 50% of the records are belonging to class 0 and remaining 50% of the records are belonging to class 1. So this is the class distribution what we have, and I've written it in the scale of 1, 0 to 1. Okay, 0 to 1. So 0.5 and 0.5.